Hello everyone, this is our first video for the playlist about algorithm and the introduction to algorithms. Today we'll start talking about what is an algorithm, and then in the future videos we'll talk about other things, other ways to represent algorithms and so on and so forth. So what is an algorithm? Basically, an algorithm is a set of rules to obtain the expected output from the given input. This may not be extremely clear right now if you've just seen this definition, but you can use this chart to get a general idea. So we have an input, and in the end we have an output. How do we get from input to output thanks to the algorithm? So we use an algorithm as a problem-solving path. So how do we solve a certain problem? Thanks to an algorithm, because it represents a path that if we follow it, we get to the final result, which is what we want. And an algorithm is a set of rules, a set of instructions. What does it mean? It means that we have an executor, which is our computer usually, and the computer is able to perform these actions. Okay, so we give it some instructions and it will execute what it tells it to do. Of course, if we make some mistakes, it won't be able to do everything perfectly, but we must keep in mind that a computer is not intelligent at all. Okay, this might sound to you a little bit contradictory, but a computer is just able to do what we tell it to do. So we must be as precise as possible because it cannot invent anything. It is not creative at all. Now, now that we know that an algorithm is a set of elementary steps executed in order, we can also say that usually we want it to solve a vast majority of problems, a class of problems, not just an instance. What do I mean by that? For example, if we want to calculate the sum of two numbers, we can call those two numbers A and B, and we want to do A plus B. So we, as users, choose what kinds of number we want. So we have A, let's say 3, and B, maybe 7. 3 plus 7 equals 10. But we don't want to just have 3 and 7. We want to choose if we want maybe 2 plus 8, 100 plus 300. We choose the numbers. It is not really useful if we have a fixed numbers, for example 5 plus 6. That's not really useful because we can use this algorithm only in the case where we have 5 and 6. So having numbers hard-coded into our algorithm isn't really a useful thing. Instead, what we want to do is putting those things called variables that we will see in future videos that will help us to change the value of the numbers we get as inputs. So we get, let's say, a sort of custom output every time, but we choose it. This is what I mean by general. Now, an algorithm should be complete and correct as much as possible. And to do so, there are some properties that should be observed in this regard. For example, unambiguity. We will see all of them, but the first one is unambiguity. So we must be able to interpret the algorithm in one way, and it must be correct. So there is only one way, there's no room for misunderstandings. Then finiteness, finite number of steps. This means that we write the algorithm and maybe we don't even know how many steps we have in this algorithm, but what we know is that there is an end. Okay, and this is really strongly connected to termination, because the execution must end after a finite time. So also in this case, we may not be aware of the time that it takes to finish the algorithm, to terminate, but we know that it will. We know that it will finish. Here I put the picture of this infinite sign, this lemniscata, let's say, and the problem that sometimes occur is infinite loops. So something that repeats infinitely and it will never stop. And this is a huge, huge problem in programming, because we want things to finish, or at least usually we want things to finish, because there are some cases where we do want something to end, to end only if we tell it to end. Okay, that sounds a bit weird maybe, but we will see this case in future videos in another playlist probably. Then effectiveness, completeness, correctness. As we said, we have an unambiguous result, but we must also consider borderline cases, some limit cases. For example, if we work with division, in case you didn't know, we cannot divide anything by 0. So 3 divided by 0, that is not actually a number, at least in the normal world, let's say. But we must be able to handle such a case. If we have division in our program, what can we do if the divisor is 0? We must find maybe something, write another routine or anything else which will help us to handle such a case. Then, as we said, generality, so solve a class of problems, not just a single case. And efficiency, so the result, we must get the result in the shortest time possible. Okay, so if you want, you can repeat all this video and you will, if you haven't understood something. But what I recommend you do if you didn't quite understand this part is just take a screenshot, read these parts, study them also in the same day, multiple hours, and it will be more clear to you probably. Now we will do something that introduces us to the next video, which is flowcharts. But before we delve into the world of flowcharts, which is basically what this whole series is about, we must talk about the Bohm-Jacopini theorem. So this theorem represents a fundamental principle in programming theory. In fact, we know that every algorithm can be created thanks to 3 basic control structures. This is how they are called, the 3 basic control structures, which are selection, iteration, and sequence. You can see here their flowchart representation. We will see what these mean in future videos, but the main thing is that we can write anything, virtually anything, thanks to these 3 basic control structures. There are also some jumps, let's say, inside our code, such as goto statements or ways to interrupt loops or get out of some if statements, as we'll see, such as break and continue, but usually they are regarded as bad programming, because anything can be written using these 3 basic control structures, and so using them can be really impactful in terms of code readability. So we should actually get used to using only these 3 and not other devices that may come in handy in certain cases, but usually we do not want them, because if someone reads our code, reviews our code, then they might be negatively marked, judged, considered, and that is not actually what we want in most cases. That being said, though, there are some cases where we should use them because maybe using only selection, sequence, and iteration, then there might be some hard things to code, to write, or the implementation might be extremely lengthy. And in that case, we can use, for example, goto statements for handling things called, for example, exceptions, which are not present in every language. But we will get more into that in following videos. Thanks for sticking with me also today. See you in the next video.